everybody. So we have finally made it here to the end of week 3, talking about the volume today of cylinders. Now, notice at the beginning here of the notes, we have an example of a cylinder and some vocab about it. We have the radius, we have the base of our cylinder, which is a circle. The height is the distance still between those two bases, just like it was with prisms. And in a right cylinder, this axis from the center to the base and the height, they are the exact same. So for all the examples we're going to talk about here today, they are all examples of right cylinders where that axis and the height are going to be the same. Now, when we talk about the volume of a cylinder, we have to go back to the fact that our prisms and our cylinders are very similar to each other, except that when we are looking for the area of the base, right, it's the same formula for a prism. We have different size and shape bases, all right? So the formulas sometimes vary when we're talking about prisms. They might be rectangles, they might be triangles. In a cylinder, your base is always a circle. So we can just take the area of the circle formula and substitute it in for big B so that it kind of simplifies the equation a little bit for us, but it does come from the same place our prism formula does. Now in the first example, again, in order to find the volume of a cylinder, you need two things. You need the radius and you need the height. And lucky for us, in this particular example, they kind of give us both here. They give us this radius, they give us this height between the distance between the two bases. So we can just plug into the formula that the volume is pi times your radius squared times that height. Now, this is a good opportunity to talk about the difference between an exact answer and an approximated answer. Even though it's not telling us which one to use here, we'll talk about both. The value pi, in general, is known as an irrational number. It's kind of the irrational number, the most popular one. And what makes something irrational is if we try to turn this into a fraction, it can't be turned into a fraction. So it's always going to be an approximated answer of some sort if we type pi into the calculator. So for a problem like this one where we want to look at the exact answer, what you're going to do is you're going to take the numbers, not pi, and type those into the calculator. So we get 4,320. And we're just going to keep pi with that number, but this is going to be known as the exact answer of this problem, right? Exact. Well, we're not going to have any approximations because we did not type the pi into the calculator. Now, let's say we want to approximate this, let's say maybe to the nearest tenth. Well, then you're going to just multiply that, type pi in the calculator, and you're going to see your approximated answer here of 13,571.7 cubic meters. So this is going to be the approximated answer. So again, talking about both exact and approximated for the second problem, this time we have to be a little bit careful because they didn't give us the radius, they gave us the diameter to start. So we have to divide that value by 2 to get our radius, and then they did again give us the height is 10. So when we're finding the volume here, pi times r squared times the height. Again, if we're looking for the exact answer, you would just do 11 squared times 10. So 210. If you wanted the approximated answer, you would take that value times pi. Okay, so again, exact answer versus approximated, pi cubed, or for the approximated, 3801.3 feet cubed. Okay, now down below, before we talk about that one, I want to take a moment to talk about toilet paper, which not only because we're in quarantine and it's hard to find sometimes toilet paper, just want to talk about it in general. If I want the volume of the paper, so how much paper I have on this roll of toilet paper, notice the middle of this, right, isn't full of paper, right? We would have to take into account that we are cutting out that central part to get the volume of paper. Well, it's the same type of problem with example 3 here. Okay, we're given a cube, but we are drilling out of that cube a cylinder so that if we want to find the total volume of this figure, it's not just the volume of the cylinder, It's the volume of, the volume of the prism. It's the volume of the prism, but we're subtracting away from it that cylinder inside, okay? So we're gonna have to keep that in mind that right now we basically need two things. We need the volume of the prism and we need the volume of the cylinder. Well, for the volume of the prism, okay, to start, we know that that is the area of the base times the height. Well, looking at this cube, if we choose a side, I'm going to choose down here, this is going to be my base. The area of that base is length times width here, which is 64 square centimeters. And then the height of this prism is also 8. So as we plug in to find the volume of this prism, the area of the base is 64, the height is 8, for a total of 512 cubic centimeters. Well, we also need to take into account, though, the volume of this cylinder needs to be taken away from it. So when we look at the cylinder, we have to be careful because they're telling us, again, kind of like example 2, that we have a diameter of 4, which means the radius is 2. And then the overall height of this cylinder is the same as the height of our prism, so 8 centimeters. So when we're looking for now the volume of the cylinder, pi times our radius squared times the height is going to be, if we just do the approximated value here, so pi times 4 times 8, we get 100.5 cubic centimeters. Well, now going back up to the top here, our total volume is the volume of this prism, which is 512, minus the volume of the cylinder, which was 100.5, for a total volume of 411.5 cubic centimeters. Okay. Now, on to the back of this worksheet. A couple things now. We have a grain silo, all right, in the shape of a cylinder. So if we sketch out just this little visual here, here's our grain silo in the shape of a cylinder. It has a radius of 4 and an overall height of 7. And we want to know what is the exact volume of this grain silo that is only half full. So a couple things here we need to take into consideration. We want the exact answer, so we're not going to type pi into our calculators, and we're going to need to account for the fact that we're only going to fill this thing up halfway. Okay, so if we find the total volume, we know that that is pi times our radius squared times our height. So again, if we're leaving this answer as exact, you're not going to type pi into the calculator. So you're just going to type in 4 squared times 7, which is 112. However, pi does go with this answer. So here's the total volume capacity of our grain silo. But because it's only half full, we need to take that value and divide by 2. So half of 112 is 56. Again, you just keep the pi with it. So your final answer, 56 pi meters cubed. Now, another way of thinking about this problem, because we're all about options here, is just instead of dividing by 2 at the end, start by cutting your height in half, because really we're only filling up halfway. So we're more so looking for the volume of a cylinder, half of this height. So another way of looking at this is finding this volume by just taking pi r squared h, which is 3.5. And if we type this in, what you're going to notice is 4 squared times 3.5 is also going to be 56. And again, the pi is just going to stay with your answer since they wanted the exact answer. So 2 ways of looking at this. Both ways gave us that same answer. All right. Now, example 5 is talking about a cylindrical pitcher. And notice it's 11 inches tall. And again, keyword diameter is 8. And if we want the overall volume, again, you have to be careful from what they're giving you. You cannot just plug this in because we need that radius in order to be able to find the volume here. And notice this time, they're not giving us any restrictions on the answer needing to be exact or that our height is cut in half or anything. So this is a pretty straightforward pi times the radius squared times the height problem. And then it says round to the nearest 10, so that means 1 decimal place. Take a moment to type all that in to your calculator. You should get 552.9 inches cubed. All right, our last two examples then are going to ask us to work backwards because notice this time they're giving us the volume. They're telling us your volume is 1767 cubic yards. What we're looking for this time is our height, right? This is the question here, is this height. So what we're going to do is we're going to plug into the formula for volume. Volume equals pi times the radius, which is 7.5, squared times that height that we do not know. Okay, that's our x this time. We don't know what the height is. Well, what we're going to do is we're going to start solving so that we get h by itself. So we're going to approximate what is pi times 7.5 squared. Well, it's about 176.7. So this right here is about 176.7. And then to get h by itself, we need to divide the 176.7 from both sides. And 1767 divided by 176.7 is about 10. Okay, so our height here is 10 yards. Now we also have another work backwards example given the volume of the cylinder. This time, however, we want the radius is what's missing. They're giving us that the height is 12 in this particular picture. And again, we know the volume is 2011, height is 12. So same kind of setup. We're going to plug in the volume, but this time, instead of having the r squared, what we have instead is the 12. So we're going to try and get r by itself. So again, to start here, we're going to combine the pi and the 12. So we're going to multiply them because everything's being multiplied right now. So pi times 12 is approximately 37.7, round up. So 2011 equals 37.7 times the radius squared. Again, our goal is to get that radius by itself, so we're going to need to divide here, all right, to get rid of that. And 2011 divided by 37.7 gives us about 53.3. Now that is not your final answer. That's the radius squared. Now you do not divide by 2 to undo a square. We need to instead square root the 53.3. You get about 7.3. So again, make sure you square root to get your final answer about 7.3, 7.4, depending on your rounding throughout this. Okay. Again, this is just going to be feet because we're not talking about the volume, we're just talking about the size of our radius. It's not cubed or squared, it's just feet. All right, that is it for week 3. Have a great time trying to practice and can't wait to see you guys later.